Okay, so in this video, we're going to work on techniques for evaluating limits. That's one of the things. So basically when direct substitution fails, what are we going to do? Okay, if we get some sort of form, so it's called the indeterminate form. Indeterminate form. And basically what this means is that we're going to get a 0 on the top and a 0 on the bottom. So we're going to have some sort of fraction, okay? And so if you do direct substitution and you get this, known as indirect form, we can do a couple things, right? We have a couple techniques. There's the easy one. It's called the dividing out technique. Okay, it's when we have to factor the numerator and denominator to get rid of some stuff. We have the rationalizing technique, okay? It's pretty much what you're thinking. You're trying to move the radical. And then last but not least, we're going to use technology. This one we're not going to do as much because we don't have, I don't have a lot of people with technology at home, but I'll show you kind of what we can do. Okay, so let's start with our first technique, the dividing out technique. Okay, so say we have this problem, and it says the limit as x approaches -3. And I have x squared plus x minus 6. I have x plus 3. So if you were to get this problem, hopefully the first thing you did was try to plug in the -3. So let's see what happens. So -3 squared plus -3 minus 6 and -3 plus 3. So this will get me 9, and then -3 minus 6 gives me also 9, and then -3 plus 3. So this essentially gives me 0 over 0. So again, this is known as the indeterminate form. So what can I do? Okay, so let's divide out. So I should be able to get rid of what's causing the denominator to become an x plus 3. So, I'm going to factor the x squared plus x minus 6. So if I factor it into x plus 3 and then x minus 2, and then this will be x plus 3, what I'm going to do is I'm going to take out what made it indeterminate, which was this guy. So I'm going to take out x plus 3 and the x plus 3. So essentially what I'm actually doing is I'm finding the limit as x approaches -3 of x minus 2. And this I can plug in. So -3 minus 2, which gives me -5. Now, you could have made a table, right, by plugging in some points. We'll still get -5 as our answer, right? But this is definitely the shorter way. Okay, so let's try another one of these. Okay, so we'll say example number 2. As the limit as x approaches positive 2 this time, we're going to say x squared plus 2x minus 8 all over x minus 2. So again, we have to check to see if we are going to get the indeterminate form. So I'm going to get 2 squared plus 2 times 2 minus 8, 2 minus 2. So this will be 4 plus 4 minus 8 all over 0, which is ultimately going to get me 0 over 0. Again, indeterminate form. So now I'll factor. So this will become x minus 2 and x plus 4 on the top, and then x minus 2. If you forgot how to factor, right, just remember you have to set up your x. And so you're taking your a and your c value, so -8, taking your b value 2, what numbers multiply, and then add to these numbers. So this will be 4 and -2, and then you set up your area model, right? So x squared, this will be a 4x minus 2x, and then minus 8. So x and x, this is 4, this is -2. If you forgot how to factor. Hopefully you didn't. So x minus 2 kind of gets away. So in reality, you're actually finding the limit as x approaches 2 of just x plus 4. This I'll be able to plug in, so 2 plus 4. And that is going to give me 6. Okay? And so our dividing out technique. Okay, let's try another dividing out technique. Let's get a little bit harder. Okay, so example number 3. So what about this one? The limit as x approaches 1 of x minus 1, and then x cubed minus x squared plus x minus 1. Okay, so again, I'm going to plug in a 1. So 1 minus 1, 1 cubed minus 1 squared plus 1 minus 1. So this will be 0. 1 cubed is 1 minus 1 plus 0. So this will be 0 or 0. So again, indeterminate form. So it's safe to say that x minus 1 is going to be factored into here. So I could do long division. So x minus 1 and see kind of what happens. So x cubed minus x squared plus x minus 1. I can also use synthetic division if you wanted to do that. So long division, so this will become x squared. And then when I multiply these together, this will be x cubed minus x squared. Again, subtract, which then turns to an addition sign. Everything cancels away, leaving you with x minus 1. So this will just be a plus 1. And then this will be x minus 1. Again, subtract, change, gives you 0. Yay! So in reality, when we rewrite this problem, right, this is really x minus 1 all over x minus 1 and x squared plus 1. What's going to happen? Those are going to really cancel away. So this is really saying the limit as x approaches 1 of 1 over x squared plus 1. Now I can plug in 1 over 1 squared plus 1. So 1 squared is just 1. So 1 plus 1 gives me 2. So 1/2. So like I said earlier, we weren't going to, we're not going to always necessarily have integers as answers. Sometimes we will have fractions. Okay, so go ahead, pause the video and try one more dividing out, a little bit challenging like this one. So the limit as x approaches 2 of x minus 2, x cubed minus 2x squared plus 2x minus 4. So go ahead, pause the video, try this one out, and see what you get. All right, so if you're coming back from the paused video, right, you should have noticed when you plugged it in, so 2 cubed minus 2 times 2 squared plus 2 times 2 minus 4. So we have to do a little bit more work on this one. So 8, 2 squared is 4, 4 times 2 is also 8, and then this will be plus 4 minus 4. So 8 minus 8, 0, 4 minus 4 is also 0, so 0 over 0. So indeterminate form, what are we going to do, right? So again, I know that x minus 2 is going to be in a factor. We did long division on the last one. Let's do synthetic division. So I would set this equal to 0. So I'm going to get x is equal to 2. So 2 goes on the outside. Remember, you're only going to use your coefficients. So 1, negative 2, 2, negative 4. So bring down the 1, and then multiply, and this gives you, and then add. It gives you 0, multiply, so 0, add, multiply, and then add. So yay, remainder of 0. We knew that was going to work. So this is originally going to, again, limit as x approaches 2. This is x minus 2. And then it'll be x minus 2, and then x squared plus, so this will be x squared. This is just x, and this is nothing. So it'll be plus 2. Those cancel away, leaving you with the limit as x approaches 2 of 1 over x squared plus 2. So we plug it in, 1, 2 squared plus 2, so 2 squared is 4, 4 plus 2. This answer should be 1/6. And that's your dividing out technique, okay? In the next video, we're going to see the rationalizing technique.